Hi everyone, I hope you're okay. On this video guys, we're going to look at the reaction between an acid and the base. This type of a reaction guys is called titration or neutralization. You are trying to neutralize the acid by adding the base into the acid, or basically you're trying to increase the pH value of the acid by adding the base into it, or you're trying to lower the pH of the base by adding an acid into it. Remember that guys, on the pH scale we have 7, 0 and 14. Once your pH is closer to 7, like your solution is regarded as a neutral solution. Are you together? So if for example you have hydrochloric acid, maybe with the pH of 1.5, are you together? For you to neutralize your hydrochloric acid, you must react it with a base, a strong base, and then when these two react with one another, you will form you'll rather increase the pH to be equal to be closer to 7 actually. Are you together? The formula for titration guys, it's simply CaVa all over CpVb. It's like this. Please remember that yes, you can say it's a concentration of an acid, volume of an acid, all over the concentration of the base, volume of the base, right? But the Na and Np do not represent the number of moles of both the acid and the base. Let's say we have we are reacting the hydrochloric acid plus sodium hydroxide. We will get sodium chloride plus water. If your acid is substance A, your base is substance B. Please note that guys, Na and Nb, they do not represent the number of moles of the acid and the number of moles of the base. They simply represent the stoichiometric coefficients. Are you together? So for us to use this equation guys, you will be given three of the things. Maybe you are short of one thing. It's either your base will be a standard solution or your acid will be a standard solution. And then let's say your acid is your standard solution, and you are given the volume of your base. You are supposed to find the concentration of your acid. You are going to use this formula because remember that a standard solution is a solution whose concentration and volume are known. If acid is your thing, is your standard solution, and you only have the volume of the base, you can simply use this formula because the only unknown you have is the concentration of your base. Are you together? But there is a condition guys for us to use this formula. We don't just use it anyhow. We only use this formula if the reaction has reached the end point. What does that mean? We only use this formula if and only if the acid and the base have neutralized one another. Are you together? Once they tell you that the reaction has reached the end point, or the acid and the base have completely neutralized one another, then you can use this equation. If you are not told anything about neutralization and endpoint, please refrain from using this equation because you will be marked wrong. The only condition for you to come here and use this is if both the acid and the base have completely neutralized one another. Okay, let's get into examples into how to apply this knowledge we just spoke about here. Okay, there's an example. We are told that 100 cubic centimeters of 0.8 moles per cubic decimeter of phosphoric acid is neutralized by excess amount of 300 cubic centimeters of 1.2 moles per cubic decimeter of potassium hydroxide. Okay, already guys, we are told that the potassium hydroxide is in excess. Are you together? So which simply means not all of the potassium hydroxide will be completely used in this equation. Are you in this reaction rather? Are you together? So for us to calculate the mass of the potassium hydroxide in excess, we must find out how much of the potassium hydroxide was used first. Are you together? We can simply say we know that we can simply use our titration equation. Let me change the color here. Let me take orange. I have Ca over Va, Cb over Vb. This is Na over Nb, right? If I choose this to be my substance A and this one B, it simply means that whenever I substitute here, remember that I have a standard solution for both acid and the base. However, I wouldn't completely use my base, so I'll take it as if I do not know the volume which was used to neutralize the base, the acid rather. So I know that the concentration of my acid is 0.8, the volume is 100 cubic centimeters, and the concentration of my base is 1.2. I want to know how much volume was used for me to neutralize the acid. 1/3. I can cross multiply. I'll simply have 3 multiplied by 0.8 multiplied by 100 is equal to 1.2 times volume. I can simply divide by 1.2 to find the volume of my base. Therefore, the volume which completely reacted with the acid is equal to 3 multiplied by 0.8 multiplied by 100 divided by 1.2. I only used 200 cubic centimeters for me to neutralize the base, but remember, initially I had 300 cubic centimeters. So for me to find the mass of the potassium hydroxide in excess, I simply need to find the volume of the potassium hydroxide in excess. How can I do that? Let me change the color. The volume in excess is simply 300, which was the initial volume, minus the volume which completely neutralized the acid. I'll get 100 cubic centimeters. So this is the amount of volume of my base which was in excess. Are you together? So for me to find the mass of the potassium hydroxide in excess, I'll simply use this equation. Concentration is equal to mass all over the relative atomic mass number multiplied by volume. I do know my concentration is 1.2. I do not know the mass of my base. The relative atomic mass number, I know that potassium is 39, hydrogen is 1, and then oxygen is 16. So this is 56 grams per mole. So I'll simply say 56 here multiplied by 0.1. Remember that, guys, the volume of the mass in excess, the volume of the base rather in excess is 100 cubic centimeters. So for me to calculate the mass of the base in excess, I must use the volume which is in excess. So the mass of my base, I'll simply cross multiply. I'll have 1.2 multiplied by 56 multiplied by 0.1. 1.2, 56 and 0.1. I'll simply get 67.2 grams. This is the mass of my potassium hydroxide which is in excess. Are you together? Okay. Now they are saying to me, calculate the pH of the solution. Please guys note that after titration, the pH of the solution will be determined by the substance which is in excess. In this case, our base is in excess, so our base is the one that will be able to give us the pH. Are you together? Let me write down the dissociation of my base. My base will dissociate into K plus OH minus. Okay. For me to calculate the pH, I must first find the number of moles of my hydroxide ions which are in excess, and then calculate the concentration of the number of the hydroxide ions rather, and then find pOH, and then go and find my pH. Okay, I do know that the excess amount, I can simply find the number of moles of my potassium hydroxide which is in excess, right? I'm just going to say concentration multiplied by the volume which is in excess. So the concentration, remember, is 1.2. The excess volume, the excess volume is 100 cubic centimeters, right? So this is 0.12 moles. So now I can then find the number of moles of my hydroxide ions, but I don't have to do the ratios here, guys, because it's simple. The ratio is 1:1, so which simply means that the number of hydroxide ions will be equal to the number of moles of my potassium hydroxide, which is 0.12 mole. So now I want to find what is the concentration of my hydroxide ions. The concentration is always number of moles all over volume, right? I do have the number of moles. The number of moles is 0.12. Now for the volume, remember that, guys, I have mixed both the 300 cubic centimeter and the 100 cubic centimeter. So the concentration, for my final volume, will be 300 plus 100, which will be 400 cubic centimeters, and this will be just 0.4. So the concentration of my OH ions is simply 0.12 divided by 0.4. What do I get? I get 0.3 moles per cubic decimeter. After finding the concentration, guys, there are two ways in which I can answer this question. I can either find my pOH and then later find the pH, or I can use my constant ionization of water to find the concentration of the hydronium ions and then find my pH. I will do both of them. Okay, I can simply find the pOH, negative log of the concentration of my hydroxide ion, negative log of 0.6. What do I get? Why am I saying 0.6? Because it's 0.3. So it's negative log of 0.3. I'll simply get 0.52. Therefore, I'll say pH plus the POH will give me 14. So pH plus 0.52 is 14. Therefore, my pH will be equal to 14 minus 0.52, which is just 13.48. This will be the value of my pH, right? But if I wanted to do it by using the constant ionization of water, I could have said concentration of H3O plus multiplied by the concentration of OH minus will always give me 1 times 10 to the power negative 14. It's a constant, guys. It's always there, né? The concentration of H3O plus, I know this is 0.3. So I can divide both sides by 0.3 for me to find the concentration of H3O plus ions. What do I get? 10 to the power negative 14 all divided by 0.3. I'll simply get 3.333 times 10 to the negative 14 moles per cubic decimeter. So therefore my pH will be equal to negative log of the hydronium ions, which is negative log of 3.3333 times 10 to the negative 14. Let me punch my calculator. Negative log of the answer. I'm also finding the same answer, 13.48. So it's up to you guys, which one do you prefer? I always prefer POH because it's more cleaner. I always prefer POH. Okay. Remember that, guys, they wanted me to find pH, né? We had a reaction whereby the base is in excess. Whenever you mix an acid and a base, the pH will always be determined by the substance which is in excess. Are you together? The base was in excess, so I know how much of the base is in excess. Initially, I had 300 cubic centimeters. I only used 200 cubic centimeters to neutralize the acid, which means the 100 cubic centimeters was in excess. Are you together? So since the 100 is in excess, I can use it to calculate the number of moles of my base which is in excess, as I did here, and then I calculated the number of moles of my hydroxide ions, and then after doing that I found my concentration. Remember that, guys, whenever you find the concentration of your hydroxide ions, remember that already the acid and the base are in one solution. Are we together? So their volumes will be additive. So that's why I have 0.4, because I summed up the 300 plus the 100 cubic centimeters to get 400 cubic centimeters, and then I found my concentration of the hydroxide ions, and then I found my POH and then pH, or I found the concentration of the hydronium ions, and then I found my pH. That's how it's done, guys, né? Okay, there's a further question to this, né? Suppose that the excess hydroxide, the excess potassium hydroxide is neutralized, is used to neutralize nitric acid. The nitric acid has a volume of 100 cubic centimeters and the concentration of 1.5. This is the balanced equation. Okay, first question, we are supposed to identify the limiting reagent between the two. Between the two, which one is the limiting reagent? I can simply calculate the number of moles of my acid, the nitric acid, NHNO3, right? I have the concentration and the volume. Concentration multiplied by volume, that's 1.5 multiplied by 0.1, which is 0.15 moles. And then for my base, KOH, concentration multiplied by volume, right? Remember that the concentration of my base is 1.2, and the volume which was in excess in the previous reaction was 100 cubic centimeters, right? So I'll simply multiply by 0.1, and then I'll get 0.12 moles. All right, together. So for me to find the limiting reagent, in this case it will be easy because the ratio is 1:1:1. But just to be safe, guys, the limiting reagent is the one that will give you the smallest amount of product. How can you detect that? I know that one nitric acid will give me 1 mole of potassium nitrate, but now I have 0.15 moles of nitric acid. 0.15 moles. I want to know how much of the potassium nitrate will I form. I'll just cross multiply. Since the ratio is 1:1, the amount I'll form is the same one that I have for nitric acid. So X is equal to 0.15. And then in this case, I know that 1 potassium hydroxide will give me 1 potassium nitrate. Since I have 0.12, it simply means that I'll form 0.12 moles of the potassium nitrate. 1, 2. Together. So in this case, guys, I can see that my base will give me the small amount of product. So in this case, this guy is my limiting reagent. KOH is my limiting reagent. The following question, they are saying I must calculate the pH of the solution. Remember that, guys, pH will be determined by the reagent which is in excess. Are you together? So in this case, the reagent in excess is my nitric acid. So I must first find how much of it is in excess, and then calculate the number of moles of my excess ions. Remember that, guys, nitric acid is a monoprotic acid, right? It ionizes to give away, to donate rather, 1 proton, like this. Okay, so according to this to this reaction, I can simply say for me to form the potassium nitrate, I know that 1 mole of nitric acid should react with 1 mole of potassium hydroxide. But in this time around, I do not have 1 mole. I have 0.12 of potassium hydroxide. I want to know how much of the nitric acid will I need for me to react with 0.12 of potassium hydroxide. And then I'll find out that I will need I will simply need 0.12 moles of the nitric acid for me to completely neutralize the sodium hydroxide. But initially, how much did I have? Initially, I had 0.15 moles. Remember that. I only needed 0.12. That means 0.03 will be in excess. How do I know that? The number of moles in excess is equal to the number of moles initial minus the number of moles which was used. So initially I had 0.15. I've only used 0.12. So the difference between the two will give me 0.03 moles. Are you together? So I now know that the number of moles of my acid, the nitric acid in excess, is simply 0.03. But for me to find the concentration, or for me to find the pH, I must find the quantity of the hydronium ions, right? I simply know that 1 mole of nitric acid will give me 1 mole of the hydronium ion. So if I have 0.03, I want to know how much of the hydronium ions will I form. I'll form the same amount. I'll get 0.03 moles. So now I do know the number of moles of my ions. I just need to find the number of moles of the, no, rather I just need to find the concentration of my hydronium ion. It's H3O plus is equal to N over V. So it's 0.03. Remember that, guys, my concentration, the total volume, I've taken the 100 cubic centimeters that was left in the previous reaction plus the 100 cubic centimeters of the acid. So I have 200 cubic centimeters, which is just 0.2 cubic decimeters. So my concentration is 0.03 divided by 0.2. I'll simply get 0.15 moles per cubic decimeter. So I can therefore calculate the pH. pH is simply negative log of the hydronium ion, negative log of 0.15, negative log of 0.15. I'll simply get 0.82 as my pH. So this is how, guys, should have gone about tackling this question. I really hope, guys, the videos are fruitful. Please stay tuned, guys, and wait for more.